All right. As you have noticed, there are a lot of appointments. I mean, there were a lot of things that was due this week because we I didn't give you a lot of due dates. All right. So this section is again it's word problem, and let me type in some question. And these are pretty hard actually. So let me type it in. Oh, I think we should make it white. All right. Make it this big. What is the smallest perimeter possible for a rectangle whose area is 16 square inches, and what the heck, I got that spelling wrong. What are the dimensions? Okay. All right, so let's look at this problem. All right. So we're looking at uh optimization. This type of problem is we'll be looking at maximize or minimize. So we're looking at area is 16, but we want to find an area. The area is 16. Oh, length times width. Length times width equal A. But when we add the perimeter, we get this. And we want to maximize it. So we have two different variables. So first, let's combine it into one variable. From that, we could say W equals 16 over L. And then we get 2L plus 2 over 16 times L equals P. So if you simplify it, you get 2L plus 2. 16, you get 32L minus 1. Now we can work with that. Because if I take the derivative of P, I get 2 plus negative 1, 32 L to the negative 2. And if we try to and if we just simplify it a little bit more, I get 2 minus 32 over L squared. And to maximize the perimeter, we got to set the derivative of P prime equal to 0. That's the critical point, and solve for L. And when we solve for L, we get 2L minus 32 equals 0. So from that, L equals plus or minus 4, and we only carry about plus 4. Since L is 4, then W is also 4. Because you got right over here. Oh, where did it go? Right over there. W equals 16 over L. All right. Okay, let's try another problem. An open box. It's a box without any top on it. Of a maximum volume is to be made from a square piece of material 24 inches on side by cutting equal squares from the corners and turning up sides. First, write one equation for the volume V of the box as a function of x. Then find the maximum volume of the box. All right, so let's look at this problem. I'll give you a couple minutes to look at it, but here is the square flat surface piece of metal, or whatever that is. That's a square. I want you to read the question. All right, so we have a square flat surface, and we're cutting equal corners. So you know how to, when you make an open box, try to visualize this. You just cut this part, but you don't cut it out. You just cut it, and then you fold it up, and it becomes a box. So we know each side is 24 inches, but if we take out this unknown corner, we don't know what this is. Let's call it x and x. So therefore, each of these sides are going to be 24 minus 2x. 24 minus 2x. All right. So let's look at the problem. So first thing first, length and width is going to be 24 minus 2x. The height is going to be just the x. So the volume for this one would be L times W times H. So you get 24 minus 2x squared times x. Volume prime, this would be, again, we use chain and product rule. 2 minus 24 minus 2x times 2 times x. Then we do the product rule right over here. 24 minus 2x squared, 1. And we set that equal to 0. What else can we factor out from that? We could factor out this part. We get 24 minus 2x. We get 4x plus 24 minus 2x. We get 24 minus 2x. If my math is going too fast, let me know. I'll slow down a bit. And from there, your x is going to be 12 or 4. We have two answers, so check it to make sure what is possible, okay? two possible answers. So we can easily check it. Now, if we say x equals 12, v equals 0. Not possible. Because look at the picture. If each of this side becomes 12, then you have no width. But when x equals 4, I get what? 4 times 24 minus 2 times 4 squared, which is 1024. That works. All right, let's try another word problem. The sum of the first number squared and the second number is 27. Find the two positive number whose product is a maximum. That's a hard one. Try that. A little bit more time. Okay, so let's look at this problem. So we're looking at sum of squared number The sum of first number squared and the second number is 27, and the product of these two numbers, and we want to maximize this part. Obviously, we have two variables. Let's make it into one variable. So we get p equals x times 27 minus x squared. Let's keep it, and we'll use product rule. 27 minus x squared plus x times negative 2x. We get 27 minus 3x squared, set it equal to 0, and our algebra gives us plus or minus 3. Now let's pick x be 3, and let's see what do we get. 9 plus y equals 27, y equals 18. So p equals 18 times 3, which is 54. And obviously we're going to use a positive number because it works. All right, let's try some more problem. A rancher has 200 feet of fencing which to enclose two adjacent corrals. What dimensions should be used so that the enclosed area will be maximum? Okay, try that one. I think we'll have our exam probably this Friday. We'll have our exam either this Thursday or Friday. I'll make it Thursday or Friday. I'll give you a couple more minutes. Maybe I'll dry it out for you guys. Maybe that would help. This is the corral. This side is wide. Try it. let's try that. So the first one, it gives us the dimension. So if I add all the fences, I get 3x plus 2y equals 200. And the area is x times y. Again, I have two type of variables. Converted all of them into one. Plug that into a equation, the area equation. If we simplify it, we get 100x minus 3x squared over 2. If we take the derivative of that, we get 100 minus 3x, set it equal to 0, and we get x to be 100 over 3. So what's y then? 100 minus 3 times 100 over 3. Oh my god, this is hard. But we have a calculator, and it will just give us 50. So the dimension is going to be 100 over 3 by 50. Alright, let's try some another problem. We're going to do this section 2 days because this is really hard. Alright, kids, let's try this one. 101, 108. Cubic inch box with a square base and an open top is to be constructed from a sheet metal of a given thickness. Find the dimensions of the tank with minimum weight. Minimum weight means is you want to get the less volume. All right, try that. I'll give you a couple more minutes. right, let's try this one. So, what's the surface area formula? Before we do that, let's draw the tank out. All right, so it's a square bottom, and that's the height. So the surface area would be, we have 4xy, because we have 4 surfaces, plus top and the bottom, which is x squared. And the volume would be, in this case, x squared times y. And that is 108. So find the dimension of the tank with the minimum weight. So let's look at this one. Y equals 108 over x squared. I think I need to write this down just in case if you guys forget. A box with the minimum weight means we need to minimize the surface area. So if we minimize the surface area, we reduce how much water it can hold. So let's look at that. From that, we could plug it in. S equals x squared plus 4x 108 over x squared. So we get S equals x squared plus 432 x to the negative 1. So S prime equals 2x minus 432 x to the negative 2. Set that equal to 0. We get 2x minus 432 x squared. We know one of the critical number is 0, but we don't care about 0 because if x is 0, it means nothing. So 432 over x squared equals 2x. X cubed then equal 216. So x is equal 6. So then y becomes, in this case, 3. So our dimension is going to be 6 by 3. All right, this will conclude today's lecture. If you have questions, I'm on the live chat.